Okay, implementing local bindings into VM. Now that the bytecode is able to represent the creation and okay, I mean before I just get started, I think can't remember, it was Saturday. Offset local. Yeah, we set up a new code. Yep, offset and get local. Compiler. Yeah, compiler produces the right opcode based on if it's in the global or local scope. Now what we gotta do is gonna handle offset. Oh, jeez. Offset and get local. Excuse me. Okay. So that's what this is. Now that the bytecode is able to represent creation and resolution of local bindings with offset and get local instructions, and the compiler knows how to emit them, the task at hand is clear. We need to implement local bindings in the VM. That means we need to first create bindings when we execute offset local instructions, and then second, resolve those bindings when we execute get local instructions. Excuse me. It's similar to the implementation of global bindings, except that the storage must now be different, must be local. Interesting. The storage of the local binding is more than mere implementation detail and can play a crucial role in the performance of a VM. Shouldn't concern the user of the VM, where and how they're stored. The most important thing is that they work as expected, which is what this test describes. Okay. Interesting. Okay. But 1 and 2. Okay. I mean, this one's pretty much the same. Excuse me. And then 3 and 4 is 4. I mean, it's the same. Okay. Yeah, this one makes sense. Global T is 50 minus 1. Okay. Thing 1, 2. And let's just add this one. All these test cases assert that local bindings work, each one concentrating on a different aspect of the feature. The first test case makes sure that the local bindings work at all. The second one tests multiple local bindings in the same function. The third one tests multiple, blah 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 blah. Okay. Obviously everything fails. How do we implement local binding? That's a good question. You know that local bindings come with a unique index, just like their global counterparts. So here too we can use the operand unique index as an index into a data structure to store and retrieve the value being bound to a name. The question is, index into which data structure? I don't think arrays make sense because it might be wasteful. And where is this data structure located? Can't just use the global slice stored on the VM, since that would defy having local bindings in the first place. We need something different. There are two main options. The first one is to dynamically allocate local bindings and store them in their own data structure. That could be a slice, for example. Whenever a function is called, an empty slice will then be allocated and used to store and retrieve locals. And there's a second option, reusing what we already have. Because we do have a place in memory where we store data that's relevant to the current function being called. It's called the stack. Yep. Now storing locals on the stack is an elaborate choice, but lots of fun to implement. Can also teach us a great deal, not just about VM and compiler, but about computers and low-level programming in general. I like the sound of that. Excuse me. Using the stack like this is common practice. That's why we're choosing this, even though we normally opt for the easiest option, because this time increased effort is worth it. Here's how it works. We come across an opcall instruction in the VM and are about to execute the function on the stack. We take the current value of the stack pointer and put it aside for later use. Take the current value of the stack pointer. Okay. When we then increase the stack pointer by a number of locals used by the function we're about to execute. Okay. The result is a hole in the stack. We've increased the stack pointer without pushing any values. Below the hole, all the values previously pushed on to the stack before the function call, and above the hole is the function's workspace, where it will push and pop values it needs to do its work. The hole itself is where we're going to store local bindings. We don't use the unique index of a local binding as a key for another data structure, but instead as an index into the hole on the stack. Okay. This is the function itself, and these are interesting. We already have the necessary parts to pull this off. The value of the stack pointer before executing the function, giving us the lower boundary of the hole. Yep, and the index that increases with every local. Can use both to calculate a stack slot index for each local binding by adding them together. Every index calculated this way serves as an offset into the hole and then points to the slot where we'll store the local binding. Okay. So what we really need is where it starts and ends. And then we just offset with the actual index. The beauty of this approach is that when we're done executing a function, since we put the previous value of the stack pointer aside, we can now simply restore it and thus reset the stack. Yeah. Okay. Yeah, that was my question too. How do we know how many local variables a function uses? But I guess this can be solved when we compile. Is it instruction? No. Yeah, but I think this can be solved. In the compiler, on the other hand, we do, and it's rather trivial for us to pass this information on to the VM. Compiled function okay, just add a easy enough. Some locals will later on tell us how many bindings this function is going to create. In the compiler, we can now ask the symbol table how many symbols were defined or compiling a function and put that number into num locals. Okay. Excuse me. Table dot num definitions. Okay, just before we leave scope. The symbol table. Right before we leave c.leave scope, take the current symbol table's num definitions, put it aside, and after leaving the scope, save it to the object.compiled function. That gives the number of local bindings a function is going to create and use in the VM. Okay, that part makes sense. This bit I'm not sure. Right before we call leave scope, we take the current symbol table's number definitions, put it aside. After leaving the scope, save it to, yeah. Okay, that gives us the number of local bindings. Now, according to our plan, the other thing we need to do is to keep track of the stack's pointer value before we execute a function and then restore it to the value after executing. Okay. So in other words, we need a temporary storage that lives as long as the function call. Okay, that's why you add it to the frame. Okay. Name-based pointer is not something I made up. On the contrary, it's common practice to give this name to the pointer that points to the bottom of the stack of the current call frame. Can't remember what the frame did. It's been a while. Maybe I remember. So that, like, I think we could push and pop frames off the stack. Maybe. No. What am I saying? No, that's not it at all. Gotcha. It's so that when we execute functions within functions, for instance, like program instructions, then we have functions within. That's what it's for. Okay. Okay, that makes sense. So we add the base pointer. Here. Oops. I've done that a few times. I mean, you'd be surprised how many times that happens during the day. It's the base for a lot of references while executing a function. Sometimes it's also called frame pointer. In the upcoming sections of this book, we'll use it even more. Right now, we just needed to push a new frame. Okay, pass it the base. The stack pointer. Okay. Question is why is it called a hole? Because when we get a new when we see the opcode for a function call. Ah, gotcha. Man, no. I don't understand. The purpose of having a hole, I mean, in the stack. In the vm.new function, we pass in 0 as the current value of the stack pointer so we can make our mainframe work properly. Even though this particular frame should never be popped off the stack and doesn't have local bindings, the setup of the new frame, in the case code.opcall branch, is what we're really after. Use the second argument in the call to new frame. The second value of vim.sp, which will serve as the base pointer for the new frame. I didn't get that bit. In the vm.new function, we pass in 0 as the current. Yep, that's the first one. Even though, yeah, it just makes it easier. The setup of the new frame, in the case code.opcall branch, is what we're really after. I think I got it. So that we don't, no, not really. Because anything that's before. Okay, I got it. So that was the missing point, because all the, what's it called, the local variables of a function have their index starting from 0. Okay, gotcha. So we use the base pointer. We now have a base pointer in place and know how many locals a function is going to use. That leaves us with 2 tasks. Allocate space for local bindings on the stack before, meaning create the whole. And we also need to implement offset and get. Yeah, exactly. It's an array, so it's just move the pointer ahead. Increasing the value of SP. And since we already save its value to the side before executing a function, yeah, I don't see what the big deal is. Just pass in the stack pointer. Okay. Now we reserve. There's nothing on the stack really. Not exactly sure what's going on. We can now use this region of the stack for local bindings and then normal usage of the stack. Offset and get. Alright, okay. So whenever we set, we just set, I think it'll be the same as global, right? Excuse me. Okay, but we increment the instruction pointer of the current frame. Frame dot base pointer plus excuse me. Does the frame have a base pointer? A little bit confusing. reason being... Right, okay, it's the base pointer. It's the starting point. Excuse me. Okay. So it's more or less the same as global. Yeah, except for this small detail. But I guess even this, yeah, it's exactly the same as global. Excuse me. It's just the base pointer that changes. After decoding the operand and getting the current frame, take the base pointer of the frame and add the index of the binding in question as an offset. The result is the index of the location on the stack to which we can save the binding. Then pop the value of the stack and save it to the computed location. Okay. Okay. Unsupported types for binary operation. In none of our test cases do we add a function to an integer. Unsupported types for binary operation: compiled, function object, and integer. Okay. Hey Reg. A good question. I'm working on a compiler. Building a compiler. Following this book. I'm currently... What am I doing currently? Oh yeah, I'm trying to figure out how to handle function scopes. It's not making a lot of sense at the moment, if I'm honest. The music is a little bit distracting. That's much better. Not really. I have no idea how to do it, so that's why I'm using the book. Makes it a lot easier. Maybe one day I can build it without the book. Yeah, it is. I mean, it's not that complex. You'll be surprised. Once I had the same impression, but once you start doing it, it's like it's not that different from what you would program on the daily. Most of the time. But there is some complexity, but like not a lot. In none of our test cases do we try to add a function to an integer. That would only happen if we leave functions lying around on the stack. We have the base pointer in place, but we don't. Yeah, that is actually a good point. I think that's where the complexity comes. Probably why it feels quite simple at the moment. Doesn't support a lot. We've got to clean up the stack. We have the base pointer in place, but we don't use it to reset pm.sp after we're done executing a function. Why do we need to reset? Ah, yeah, because the stack pointer is pointing, yep, to the end of the. Yeah. So on return, stack pointer needs to be. Gotta remove the base pointer. Okay. Normally, yeah, I would say. That's what I do normally. That's a good guess. How did you know? By normally I mean like for work. Okay, cheers. Translate. No. We only take the term value and just executed function of the stack. Now we get rid of the local bindings too. The easiest way to do that is to set the stack pointer to the base pointer of the frame that holds the just executed function. What's that mean? Yeah, just y base pointer -1. No, you run in Linux. I don't know what's lean UI. No, it's just Linux. GNOME. Yeah, think so. It's just Ubuntu. Well, version of Ubuntu, I think. I'm curious, which post were you reading on the blog? Or like, how did you find the blog? Did you just Google something and then it came up? Because the only reason I ask is I write about random shit. And Oh yeah, because before we update the base pointer and the stack pointer. Okay. When we return from a function, we first pop the frame of the stack. Previously we also did that, but we didn't save the popped frame. Right, okay, gotcha. Because I thought you found the block first. Fair enough. Where is the... Yeah, I had the same question. It's an optimization. Setting VM to frame the base pointer. No, I'm from India. Excuse me, I'm from India. No, that sounded weird. Okay, so we do the -1, so we pop the function of the stack too. Yeah, I think you know the first one. Someone said that before too. I guess we look similar. Instead of keep on the VM the pop we previously had in place, we replace it by... Okay, gotcha. Definition. Okay. There's a few things to do. Don't know which ones. Okay, let's go to call. But first we need function literal. Is it? Yeah. Okay, here. Could update this object to have number of instructions. Should be U64. Yep. Then dot num instructions equals instructions.len. No, I live in Thailand. I don't live in India. Okay, that's correct. Instructions.len. No. Don't think it's the instructions I need. Auto modded. What for? Let me check. I don't see anything here though. Usually it shows up. I thought I would be able to see what you sent. Yeah, exactly. Okay, gotcha. I know you got banned for that. Or like modded for that. It's not function instructions I need. Yeah, it's okay. I don't know. Maybe it doesn't like things you're shouting. No, but not really shout. I don't know. I don't know how it works. It's a mystery to me. I don't think anyone does. What I need is excuse me. I need to know how many variables I allocate. What time is it in Thailand? It's 5:30 in the morning. Excuse me. Okay, it's almost midnight. So you live to the west of here. Yeah. No, you live to the east of here. Further. I don't know. Maybe. No, the west. Yeah, okay. My first guess was correct. Because the time goes back. Okay. Can't remember. What did I save in the scope? Instructions. Ah, yes, I need it from the symbol table. I need the symbol count. No, I usually wake up at 4 a.m. because it's the only time I can work on my side project. I'm quite lazy during the day otherwise. I tried doing it after work, but after like, let's say 5 or 6 o'clock in the evening, I'm too lazy. But I found in the morning, I find it a lot more easier to to do this. That's why. Not really, no. I am quite lazy, you have no idea. I wake up early. I think that's the only Goggins thing I do. Otherwise, I would say I'm quite lazy. I find it quite difficult to get things done. Hey, but I'm trying, so I think that's the best you can do, right? Say symbol. I think it was hard for. I think it's still hard, I would say. Been waking up early for now. April, May, June, 4 months. I mean, now it's not that hard. But the first week was like sort of. I couldn't sleep at night. That I was waking up like after 4 hours of sleep. Now it's not bad. I just wake up, don't even think about it. I'd say more than the first week. The first month was hard. Excuse me. Symbol counts. What time do you normally wake up? I mean, it's midnight. Yeah, I guessed. I guess it depends on what works for you, right? I only started doing this because I realized after. Okay. I mean, I think it really doesn't matter because I can wake up at 4 a.m. and do nothing the whole day and makes no difference. Yeah. I think it depends on what works for you. Because after like 6 or 7, I find that I'm totally useless. So if I thought, okay, might as well just go to bed early. Yeah. Because the mornings I find that I'm very productive. But after 12, it just starts going down. And I guess it ends up being the same thing, really. If you wake up early or later, because you don't get like more hours in the day. But I think, when was it? Sometimes I'm quite sleepy and I fall asleep at around 12 in the afternoon. And then I wake up by like 3 or 4. I find that it feels like I have 2 days in the same day. Because then I go to bed late and then I wake up at 4. It's a weird feeling. It does feel like there's more than one day in the same day. Yeah, got that. Uh, 64. Okay, that makes sense. Yeah, 6 to 10, and then from 1 to 6. Yeah, it's a strange feeling. Feels like we've been living, got like one extra day or something. Program instructions, and then let's pick. Yeah, I used to love it. I only watched Dragon Ball Z. I don't think I watched the others, just Dragon Ball. They have this thing called time room or something. Oh, is it the time room or like the capsule thing? Oh yeah, I think I remember. It's where like you can turn up the gravity and stuff, and then Goku trains at like 100G or something like that. Is that the same thing? Okay, yeah. Yeah, it's a pretty cool idea. I read someone who mentioned something about it, but I can't remember. It was like a long time ago. Oh, oh. I watched it again recently. Dragon Ball Z. Not all of it. I think it was maybe a few months ago. Dragon Ball Z. I think it was when they fight Frieza. I was watching that one, that section. I think that's my favorite part of the show. I didn't watch anything after, but I think that was the last that I watched when I was younger. Upset Global. Yeah, I used to watch it as a kid. It used to come. Okay, yeah, fair enough. I mean, I'm not that busy. Got a lot of time on my hands. It's just not really that good. Don't like it that much. You are you into programming too, Rage? Working 9 hour shifts, 6 days a week, and it's tough. Yeah, it sounds like. Yeah, it's nothing. I mean, I think it's the same here, but I work remotely for myself. So it's not there's like sometimes, for instance, from I think January to April, like for 4 months, I was working like 7 days a week and pretty much all the time, like at least 12 to 14 hours a day. But that was because there was a lot of new things to be done. But since then, now I work like maybe 7 hours a day at most. Yeah, but there was like there's only like sometimes. And it might sound crazy, but I preferred when I was working that hard to now, where it's like not that busy and I don't like all the extra free time. Find that there's too much time for like overthinking. Yeah, I guess that's fair too. There were like some days during that time where I was like quite exhausted. But it's only like maybe 2 or 3 months in a year at most. Not every year either. Just some years. Where do I save vocals? I'm trying to learn Python. Do you want to be a programmer? Is that why? Or is it like just for fun? You wanna build something for yourself? Mm-hmm. Don't know where this goes. Okay, I'm currently working as a sysadmin at a small tech firm. I found when I was, yeah, I mean, that's fair enough, right? I found when I was trying to learn, what helped me was doing it with like other people. Too many tickets. I don't know what a sysadmin does. Oh, okay. Yeah, it's kind of like IT. How are you trying to learn? Don't know. Saving it to globals doesn't make any sense. Interesting. So you push it back onto the stack. Hmm. I want to see how globals were done. Function calls. Adding globals. Okay, so I wasn't wrong. Filing. Yeah. No, not this one. Implementing. Okay. Guess the only thing I need to change is self dot. My learning strategy is quite simple. Just learn the basics, play around, document what I learned, that's it. I don't like to follow online courses. Yeah, I was not gonna like suggest courses because I don't like it either, because I just find them to be like a waste of time. But what I was gonna suggest is like you could join some communities where people are trying to learn. I find you learn much faster. I can like share a few. This one's like, I think it's called Code 3. I don't know if they're still active. Yeah, this is where I learned. And you just like do the same thing but with other people, and it's like completely free. It's pretty good. But this is JavaScript. I think for Python you can try bootdev. It's also pretty good. I'll just leave the link here. You can like pick either. They're both very good. This way you can learn with like other people. It helps a lot. Green dot symbol. No. Yeah, they're both really good, I would say. And I mean, they're both good for the same reasons. Like, whenever you get stuck, or like, let's say you try to solve some problem, you can share your code, and then other people will like review it. You learn a lot faster that way. Because I think when you're trying to learn by yourself, that's the biggest challenge. Like not knowing if the code you're writing is any good. So when other people look at it, and you get the feedback helps. Yeah, I mean, to be fair, that's how I heard it too, from the Primogen. Base pointer. Where's the frame defined? Okay. Base pointer plus identifier index. Yeah, I love him too. I think this is really good. Set local, and then I need one for global. Back. Frame dot base pointer. I think that's everything. Oh yeah, go to reset. I think I need the return value. You too, Rage. Have a good night. Thank you for hanging out. It was nice to talk to you too. And good luck with Python. Okay, now remove a frame. Hang on. I need to return the base pointer. Return the frame. Does that make sense? Previous frame. Okay, gotta do all three of these things. Can't remember what I'm doing. Gotta increment the stack pointer. Equals. That's equals. Dot symbol out. Then on return, goes previous frame dot base pointer plus 1. Guess I can remove this assertion. And that works too. Yeah, I think that's kind of looks better. And I guess do the same. Yeah. I have a feeling it's going to be some off by 1 errors. Okay, one way to find out. Two, three. Just copy the test. I'm gonna test this one. And this will be 1 and 2, 3 and 4. 3 plus 7, 10. Then this kind of the same, is it? Yeah, no, this one's good too. Expected 50. This is last one. Good. Okay. And this will be what's expected, 97. Okay, I think there's gonna be quite a lot of errors. Missing field, symbol count. Compiler 941. Right, okay. Symbol count equals 0. Ooh, there's gonna be quite a few. 965. Constant 1 to 990. Symbol count equals 2. Oh, I forgot to save. $1,001. There's a typo. Symbol. 2014. Two. 38. One. 1061. Zero. Jeez. How many more is there? Zero, 5. Should be 0. One, 3, 3. Symbol count is 1. 68. It's 1 and 2. Okay. PM.6. Missing field, symbol count. 403. Actually, it's a 0. Because it's the main function. I use globals to track that, so it should be fine. $39. Base pointer. Missing field, base pointer. What do you mean? 38. Okay. Yep. It's correct. Pointer equals. Guess this can be unsigned. self dot add frame. I'm not too sure about this bit. Stack pointer plus equals symbol count. Not sure. No fields named symbol count in object. Okay, yeah, that's correct. It's a typo. I think I'll do the same for frame. Just be AU32. Can't be bigger than the stack anyways. Need to fix the compiler. $275. Minus equals instruction dot sym symbol count. $350. Self dot current frame. Self-taught frames. Yep, I didn't expect it to pass. Reached unreachable curve. Assertion failure. $3.23. Check. Up call. Function local 1, local 2, stack pointer. Yeah. Stack pointer should go beyond. Yeah, so I think it's plus equal to symbol count. Okay, so it's base pointer plus number of locals. Right, because offset local would set the values here, so the stack pointer needs to be pushed beyond. I was right to think that would be wrong. Yeah, actually it's plus equal to. Yeah, so I think it's the same thing. Frame dot base pointer plus number of locals. Base pointer is just stack pointer. Yeah. Stack pointer. 23. So what's there at this point? Check dot integer. Of course, I'm off by 1. Hang on. That's the main function. No, it's not the main. Sorry. It's the return value. Really print it. Hmm. Hang on. Because this is no longer required. I'm correct. Frame dot base pointer. Yeah, I never used this. Don't think we need this anymore. Minus equal to previous frame dot base pointer. constant x. Yep. No, I should get the return value first. Yep, I'm off by 1. Let's go in. Actually, I know why I didn't want to do -1. So I wanted to assert I was removing the right. Yeah, now I remember. Previous frame dot base pointer. I don't need to return anything. Move frame. Yeah. So if I look at that, yeah, that's the function. Yep. Oh, why? I need I need the previous frame. Delete that. Then the stack pointer should be the base pointer. Now I need to get the return value first. Should be whatever is at the top of the stack. Yeah. Then here, this should be previous frame dot base pointer. Everything else should be fine. Obviously, it isn't. 324. Okay, it's null. Nah, I'll leave this out for now. Okay, I think I'll complete this tomorrow. I think there's quite a few mistakes. Okay, I'll figure it out tomorrow. I'm gonna call it a day there. Okay, say thank you for hanging out. I'll see you back here tomorrow. See ya, and